Okay, we're going to try this again. This is like my third or fourth time trying this video. I'm hoping it works this time and I don't make a mistake. Anyways, I hope you guys are behaving for the sub. This is 8.1 day 1, use trigonometry with right triangles. I have some of the stuff already written out on the screen, so hopefully make this a bit of a shorter video. Okay, so on the day before the SAT, we did a little remembering of trig. For those of you who've had trig before, I know some of you did not take geometry, so you've not had trig before. But these are the 6 trigonometric functions. The stuff in red is stuff you should have had already if you took geometry. We have SOHCAHTOA and friends. SOHCAHTOA stands for sine, cosine, and tangent. I'm going to try and use this little thingy here. So sine, cosine, and tangent. Over here we have them written as well. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's where SOHCAHTOA comes into play. If you can remember that, you can remember what sides go where in our fractions. This all has to do with a right triangle, which is what we have over here. So in the right triangle, across from the right triangle is always going to be the hypotenuse. Here is our theta. This is the circle with a little curly Q on it. And it doesn't matter where the theta is, whatever across from it is called the opposite. Whatever next to it is the adjacent. If we would move and have theta up here at top, then across from it would be the opposite. And then next to it here would be the adjacent. So it all is dependent on where your theta is as to which side is opposite and adjacent. But hypotenuse is always across from the right angle. So if you were in geometry, you learned about SOHCAHTOA. Now we're going to learn about SOHCAHTOA in friends. So the friend of sine is cosecant over here. It's abbreviated CSC. And its fraction ratio is just the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Cosine's friend is secant. And again, it is just the reciprocal as well as hypotenuse over adjacent. And then tangent's friend is cotangent, which is adjacent over opposite. So the way I like to remember this is that the C's do not go together. These co's do not go together. Each pair has SC, sine, cosecant, cosine, secant. So that's how I keep track of it and try and remember it. Okay, so let's try out a math problem. This is where I screwed up in the last video, so we're going to see if I can do this one without screwing up this time. Cross your fingers. Okay, so first thing we need to do in this right triangle is find the third side. So we're going to do the Pythagorean theorem to find the hypotenuse here. So 5 squared plus 12 squared equals x squared, because side squared plus side squared equals hypotenuse squared. This is 25 plus 144 equals x squared. So 169 equals x squared, square root, and x equals 13. This is called a Pythagorean triple because all of the sides are very nice numbers with no roots or decimals. So we're going to label each side here to help us out as well. Across from the right angle is the hypotenuse. Here our theta is up at top, so across from the theta is our opposite. And next to our theta is the adjacent. So we're just going to set up our 6 trigonometric functional ratios. So the sine, remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So for sine, opposite over hypotenuse is just 12 over 13. And then the cosine is adjacent over hypotenuse, which is 5 over 13. And then the tangent is opposite over adjacent, which is 12 over 5. And then SOHCAHTOA and friends, all their friends, you just need to do the reciprocal of all of these. So cosecant then would be 13 over 12. Secant would be 13 over 5. And then cotangent would be 5 over 12. And then those would be your 6 trigonometric functions. Okay? Now, they're not all going to be this easy because we're not always going to have a Pythagorean triple. And that's going to be with this problem. So we need to find the third side here. So we're going to do the Pythagorean theorem, which is side squared plus side squared equals hypotenuse squared. So 4 squared plus x squared equals the hypotenuse, which is 7 squared. So 16 plus x squared equals 49 minus 16. X squared equals 33. We need to see if we can break down this root. 33 is 3 and 11. There are no pairs, so we can't break this down. So this actually stays root 33. Okay, so again, if you want to label your triangle, across from the right angle is your hypotenuse. Here is our theta over here on the left. So across from that is the 4, so that's the opposite. Next to that here is the root 33, so that is the adjacent. One thing that sometimes helps students is if you always write SOHCAHTOA at the top of your page so you can remember the fractions. That is very helpful for some people in quizzes and tests because you will need this. We're going to need this back, I think in Target 3 or 4, we need to know SOHCAHTOA again in a slightly different way. I want to do the darker blue. There we go. So the sign here is opposite over hypotenuse. So the opposite for this one would be 4 over the hypotenuse of 7. The cosine is adjacent over hypotenuse. So the adjacent is root 33 over the hypotenuse of 7. And then the tangent is opposite over adjacent, which is 4 over root 33. Now, if you remember back from Unit 2, we cannot have a root on the bottom of the fraction. It is a very, very bad thing. So we need to do what's calling rationalizing the denominator to get that root off of the bottom. So we're going to multiply the top and the bottom by root 33. So here on top we have 4 root 33. On the bottom, root 33 times root 33 is just 33. Now, you do always want to check to see if you can simplify this fraction, 4 over 33. You can't in this case, so we are done. That's your answer. But sometimes you might be able to simplify that fraction, and if you can, you need to. Okay, so the and friends part, we need to do the reciprocals. I have not been yawning all day, and I start this video, and now I'm yawning. I'm sorry. So this is 7 over 4. Secant, if we flip it, this becomes 7 over root 33. Uh-oh, we got a root on the bottom. Can't have that. You got to multiply the top and the bottom by the root. So this becomes 7 root 33 over 33. Can we simplify 7 over 33? Nope, we cannot. If you don't know how to check that, you just do 7 divided by 33, math, enter, enter, and see if it simplifies the fraction for you. And it does not. It stays 7 over 33. And now here for the cotangent one, you can make this really easy or really difficult for yourself. I'd go with the easy way if I were you. I'm not going to flip this one. That would be atrocious because then you're going to have to do a radicalizing the denominator again. I would go back to this original one over here and flip that. So this becomes root 33 over 4 for our answer. Questions? I'm not here to answer them. You can save them for a Tuesday. Okay, so let's try another one. This is very similar to it, except this time we just don't give you a picture to go along with. So first of all, everyone should get at least one of these 6 correct because they tell you what. Cosine is 7 over 10, and I'm going to go ahead and flip that, and that means a secant is the reciprocal of 10 over 7. Okay, so everyone should get those 2 correct on here. Find the other 5 trigonometric functions of theta. So we want to draw a triangle. There's my triangle. This is my right angle. It does not matter which corner you put theta in. I'm going to put it down here on the bottom, but if you put it up on the top, it's fine. I'm going to write SOHCAHTOA out on top again to remind myself. And then I need to label it. So cosine is adjacent over hypotenuse. So that means the adjacent is 7. So that's this side. The hypotenuse is 10. And we need to find the third side. So we're going to go back to do the Pythagorean theorem. This is going to become your best friend in this unit. We're going to use it a lot. So 7 squared plus x squared equals 10 squared. 7 squared is 49 plus x squared equals 100 minus 49 to both sides. X squared equals 51. Root. Can we break down 51? I don't believe we can. 51 divided by 3 is 17. And 17 is a prime number, so that can't be broken down. So this is just going to stay root 51. Okay, so then sine is opposite over hypotenuse. So sometimes people like to label these O, A, and H, so it might be a little bit easier to do these problems. Sine is opposite over hypotenuse, so root 51 over 10. Tangent is opposite over adjacent, so root 51 over 7. And then we need to flip all of these. So 10 over root 51. Uh-oh, we need to rationalize the denominator. Multiply both sides, or the top and the bottom, by root 51, so we get 10 root 51 over 51, which cannot be simplified, so that would be your simplified answer. And cotangent, we would need to flip that. Uh-oh, root on the bottom again. Can't have that, so you're gonna, oh, I wrote 15 there. Oh, goodness, Miss Teal. Okay, we're gonna try that again. 51, but I am not starting this video over again. It's Sunday afternoon, I wanna go home. So this will be 7 root 51 over 51. Again, you cannot simplify 7 over 51, so that would be your final answer. Okay, hope you all are feeling okay with this. You have a homework assignment. The sub hopefully should have passed it out to you already. Give it a try. There's only 6 questions, I think, on, ooh, don't flip, there we go. There's only 6 questions on it, I believe, so give it a try. Tomorrow, on Tuesday, we're going to do some more advanced stuff on when we're trying to find angles, and we're given the sides of the triangle, but we don't have the angles, okay? Make sure you have your calculators for that on Tuesday. You won't be able to do it without a calculator. Okay, hopefully you're all behaving for the sub, and have a marvelous day. I gotta try and figure out how to turn this off.